Greetings once again. Today I want us to do the homework that I gave you last time. And the homework looked something like this. And we said that the question was calculate the exact value of this. And you will notice that if you try to punch this in a calculator, you will get an error message. So now we wanted to make sure that you can get the exact value of that by using laws of exponents and also try and simplify these basic expressions and also solve for x here and rationalize this. So how do we go about that? Let me try and open a different file here. I want to open a different file. Let me see. And close. Open again. I want to see the file there's a file that I want to use here. So that we can use to, yeah, I want these work notes. Yeah. So for this, I wanted to use this, not OneNote. So the question was, we want to find the exact value of, let me do this, exact value of 10 raised to exponent 2009 and then divided by 10 to the exponent 2011 minus 10 to the power 2007. Now, the first step is very simple because you can see that 10 to the exponent 207 is contained in 10 to the power 209 and also is contained to the power 10 to the power 2011. So first of all, we wanted to make sure that we change this to have, we want to change this to have 10 to the power 2007 and this to have 10 to the power 2007. So to do that, this is going to be the same as 10 to the power 2007. How much do we need to add in order for us to get 2009? So we just need to add 2 and then divided by square root of 10 to the power 207, and then how much more do we need to add there to get 2011? So we just need to add a 4 minus, we keep this as it is, so you're gonna have 2007 here. And then once we have that, you know that we said that when multiplying powers of the same base, we add exponents, and when dividing powers of the same base, we separate exponents. Here we have the addition here and there. So what we need to do, we want to split that. So we're going to have 10 to the power 2007 and then times 10 to the power 2, all divided by square root 10 to the power 2007 times 10 to the power 4 minus square root. We leave that as it is. And then we go down and say, okay, fair. We already have this nice thing there. What next do we need to do? We said that if you have a product inside a square root, we can always split that, or we can always combine them. So what we will do here, we'll try and split that, and we say, okay, this is supposed to be the same as 10 to the power 2000 times the square root 10 to the power 2. Take note of this. We have a 2 there, we have a 2 there, so we can always combine them or split them. We're going to do the same thing here. We have 10 to the power 2007 times square root 10 to the power 4 minus square root 10 to the power 2007. Right. Now that we have that, we're gonna take out the common factor, which is the square root of 10 to the power 2007. So in the numerator, we still have 10 to the power 2007 times 10 to the power 2 all over, and then in the denominator factorize 2007, and then we're left with the square root of 10 to the power 4 minus a 1, because we have taken out the 10 to the power, the square root of 10 to the power 2007. Now that we have that, you can clearly see that we have a common factor here. This, let me pick a green. This and that is common, so we can take it out, and now you are left with 10 square root 10 to the power 2, and then divide by square root of 10 to the power 4 minus a 1. Now when you look into that, remember that because 10 is positive, so we can apply the rules in number 4. So we're gonna have 10 to the power 2, because there is nothing there, which means there is a 2. So you divide by 2, and then you have 10 to the power 4 divided by 2 minus 1. Now, if you look close to this, 2 divided by 2 is 2, so you're gonna have a 10, and then here you're gonna have a 10 to the power 2 minus 1, which is the same as 10 divided by 100 minus a 1, which is just equal to 10 divided by 99. That's how you solve this one problem. It's not that hard at all. Now, the next problem that we had at hand was, let me look for this. The next problem was mathematics for science, lecture 1. The next problem that we had, let me go at the last. So the next problem, we wanted to simplify this. How do we simplify that? It's very simple. Let me look into it. We have 2ab cubed divided by c squared all to the power 4. So we want to simplify that. In other words, we just don't want this 4 there. So what we do here, we just rewrite that because we wanted to simplify. We had 2ab cubed all over c squared all to the power 4. How do we simplify that? This is going to be the same as, I'm going to place a 2 to the power 4, and then a to the power 4, and then b to the power 3, but now this is to the power 4, right? And then all over c squared all to the power 4. Remember the rules. The rule we had here was that if you have this thing all to the power 4, it means that we can give it each of these terms power 4. Now that we have that, what is that equal to? 2 to the power 4 is 2 times 2 times 2 times 2, which is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we're supposed to have a 16 there. And we're supposed to have a to the power 4. And then whenever you have a power of a power, you just multiply the 2. So you're going to have b, and then 3 times 4 is a 12. That's how you go about that. And then in the denominator, whenever you have a 2 and a 4, power of the power, just multiply the exponent. So it's going to be c to the exponent 8. That's all there is to it. It's not hard at all, of course. Now, let's go to another one. This one is a little bit longer. So we have 8. So this one is supposed to be, we have 8 to the power n plus 3 times 32 to the power minus n minus 1. Let me check again. And 32 and minus 1 minus 1, and then we have 6 to the power 2n, and then times 6 to the power 2n, 2n all over 9 to the power n, over we have 9 to the power n. Now how do we solve that? Now to solve this, all you have to do is, we want to change 8, we want to change 32, we want to have change that 6, we want to change the 9, so that if there are some common factors we can cancel them out. That's why we're changing them. So 8 is the same as 2 to the power 3 and 2n plus 3 times, what is 32? 32 is 16 times 2, and we know that 16 is the same as 2 times 8, and 8 is the same as 4 times 2, and then 4 is the same as 2 times 2, which means that 16 is the same as 2 to the power 4 times 2. So this is supposed to be 2 to the power 5 raised to minus n minus 1 times 6 is the same as 2 times 3 to the power 2n. And then 9 is the same as 3 squared raised to the power n. So how do we proceed with that? So this is going to be 2, and then whenever you have a power of a power, so you always multiply the exponent, so it's going to be 3 times n plus 3, and then you're gonna have times 2 times 5 times minus n minus 1 times 2 to the power 2n times 3 to the power 2n. This is 2n. This is 2n, guys. This is 2n. Yes. And then you divide this whole thing. Let me do this. Yeah. Divide this whole thing by 3 to the power 2n. Now we have 3 to the power 2n in the denominator, and you have 3 to the power 3n in the numerator. So what we do here, we cancel this, we cancel that, so it's gone now. So the only thing that we are left with is 2 raised to 3 times n is 3n plus a 9. 3 times 3 is a 9. Times 2 to the power minus 5n minus 5 times 2 to the power 2n. That's what we are left with at the moment. So once you have that, when multiplying powers of the same base, you add the exponents. So you're going to have 2 to the power 3n plus a 9 minus 5n minus 5 plus 2n. So that's what you are left with there. And then you continue. 3n, we collect some like terms. 3n minus 5n, that's minus 3n. Minus 3, that's minus 2n. Minus 2n plus 2n is a 0. So you still have a 2, but this part and that part and that part, they add up to 0. And now we have a 9 minus 5, which is a 4. What is 2 to the power 4? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the answer we're looking for here is a 16. Now, let's go to number 4. Number 4 is not that bad. It's not that bad at all. So here we also wanted to have a nice drawing. Let me do this. So for this one, let me take this out. For this one, this is the same as, I'm going to multiply the square root of 5 and the square root of 5, so you get the square root of 5 squared minus the positive and the negative, they give you a negative. So you're going to have a square root 3 times the square root 5, and then we also multiply this with that. So we're going to have a plus square root 3 square root 5. And then after that, we multiply these last terms. So we're going to have a minus square root 3 squared. So the answer we're looking for, this part and that part, they cancel out and they are gone, they add up to 0. So you end up having the square root of 5 squared. Square root of 5, we know it is a positive number, it is defined. And we don't know what it is, and we square it up. So we can switch these two around. 5 squared is 25. The square root of 25 is always positive, so we're going to have a 5. We do the same thing here with the square root 3 squared. We're going to have minus 3. So the answer we're looking for here is a 2. That's how simple this is. And now this part over here is the one that we'll deal with. Let's go to this side for it. So for that, you have a square root of 21 times the square root of 60 times the square root of 35. Let me double check. Okay, 21, 60, and 35. Now, what is square root of 21? Square root 21 is the same as 3 square root of 3 times 7 times the square root. If we look at 60, 60 is the same as 30 times 2. So we have 30 times 2. You can break it down like that, 30 times 2. And then this one, you can see 35 is the same as 5 times 7. So let's continue to break this 2 times 30. So we're going to have 3 times 7. And then we break this one down. It's going to be 2 times 5 times 6. And then this one is going to be 5 times 7. What we are trying to do here, we wanted to break this down into its prime factors, what we call prime factorization. So we're going to have 3 times 7 here, and then here we're going to have 2 times 5 times 2 times 3. So square root 5 times 7. So 6 is the same as 2 times 3. So this is going to be, now that we have this, we have a square root and a square root and a square root. So we want to combine everything in one square root. So we have that. So we're going to have, how many trees do we have here? We have 1 tree, 2. So we have 3 squared. And how many 7 do we have? 1, 7, 2, 7. So we have 7 squared. And then after those 7, how many 2's do we have? 1, 2. We have times 2 squared. And then how many 5's? We have 2 5's. So we have 5 squared. Now that we have this nice thing here, you can see that this is the same as whenever you have 2, 2, 2, we can always combine this. We have 3 times 7 times 2 times 5 all squared. Now, if you look at 3 times 7 times 2 times 5, this is positive. So squaring it up is positive, it's defined. Even if we start with the square, it's positive. So these two can actually cancel out, so it's fine. So we're going to have 3 times 7 times 2 times 5. So this is, so 3 times 7 is 21 times 2 times 5 is a 10. So the answer you're looking for is 210. Because multiplying by 10 is just adding 1 0. So this one also is not that hard. It's easy. Now, we are faced with this. We wanted to find the value of x for this particular equation. We're saying it's an equation because it has an equal sign. These are expressions because there are no equal sign. This is also an expression because they don't have an equal sign. So let's try and solve for x in this particular equation. So this one we have a to the power, let me look into it, a to the power x, we have a to the power x times the x root of a squared all over, let me go back, a to the power x minus 5, a to the power x minus 5. Is it x minus 5 or 5 minus x? Or 5 minus x. So here we have a power minus power 5 minus x. This is equal to a 1. Now, we can see that on the left hand side we have a's everywhere. On the right hand side we have a number. So, first we have to realize that if a is not equal to 0, to the power 0 is equal to 1. So we're going to change this one to be a to the power 0. Right. We assume that a is not equal to 0 because if a is equal to 0, this was going to be a 0 and this whole thing on the left is going to be undefined. So we assume that a is not equal to 0 because of what was going to happen on the left hand side. Now, we have a to the power x and we have a to the power 2 divided by x. We are changing this x, we're changing this x root to be a 2 over x, because we can always take this thing that is outside and divide what is in the inside. So we're gonna also have a to the power 5 minus x there. Now that you have this nice thing, the next thing that you have to do, you have to realize the rules. The rules are saying when multiplying powers of the same base, add exponents. When dividing powers of the same base, subtract exponents. The base here is a everywhere, so we can apply the rules. So we're going to have a to the power x plus 2 over x all over a to the power 5 minus x, and this is equal to a to the power 0. And of course, when dividing powers of the same base, subtract exponents. So you're going to have a to the power x over 1. X is the same as x over 1, so it's still the same thing, plus 2 over x minus 5 minus x is equal to 0 to the power is equal to a to the power 0. Take note of what I have done now. It is common for students to actually say this is correct answer, but remember that we're supposed to have the brackets there. Don't miss the brackets, because if you miss these brackets, this sign here will actually be wrong if these brackets are not there. So we proceed, and we know that the left hand side is going to be a to the power x over 1 plus 2 over x minus 5 over 1. Minus and a minus will give you a positive. So we're going to have x over 1, which is equal to a to the power 0. Why am I adding these ones there? I want to have a common denominator. That's why I'm doing that. But 1 is not changing anything there. Now, since we have this whole thing there, I'm still going to have an a, and what is the common denominator there? You can notice that if x is equal to 5, 5 does not go to 1. But if we have 1, 1 goes to 5. So we just say, okay, the common denominator there that we must have an x, because 1 goes to x times. Right, so we're going to have a common denominator, which is x. Suppose that x was not going to 1 and 1 was not going to x. What was going to be the common denominator there? We're going to say 1 times x will be our common denominator. But in this case, 1 times x is still x. So we're going to have an x there. And then x divided by 1 is x. X times x in the numerator is going to be x squared. X divided by x is 1. 1 times 2 is still going to be a 2. X divided by 1 is x times minus 5 is going to be minus 5x. X divided by 1 is x. X times x in the numerator is going to be plus x squared. So this is going to be equal to a to the power 0. Now, we have this and we have a and a are the same, and we have this equality there, which means this thing on the left is equal to that thing on the right. These bases are the same, which means the exponents should be the same too. So which means that x squared, because we have this x squared here and that x squared, so this is going to be 2x squared. So 2x squared minus 5x plus a 2 all over x is equal to a 0. Now we are there. But take note that x, if x is equal to 0, the expression on the left hand side of the equal sign is going to be undefined. So x cannot be equal to 0 because this expression would be undefined on the left. Now we are only left with this. For this thing on the left to be equal to 0, we need 2x squared minus 5x plus a 2 to be equal to a 0. That's the only way this thing on the left will be equal to 0. We're not cross multiplying anything here. I know that if you are tempted to cross multiply, you can, because x is not equal to 0. We just declared that. But another way to look into this will only be equal to 0 if the numerator is equal to 0. Now, how do we solve this? We solve it by factorizing. We have to factorize that, or we use the quadratic equation here. Because we're not going to be using a calculator, we might make mistakes here and there, but let's just try and factorize this. How do we factorize this? It's very simple. The first thing is you take the first term, which is 2x squared, and you multiply by plus a 2. So you're gonna get a 4x squared. Now that you have a 4x squared, which is a positive, we want to use the splitting of the middle term method. So we want to have the factors of positive 4x squared such that when I am adding those two terms, I get a minus 5x squared. Because we are adding those two terms, both the two terms must have an x in order to produce a minus 5x squared. So we are looking for two terms which must have an x, such that if I'm adding them, I get a minus 5x. And these two terms we are looking for, the same two terms, if I multiply them, I get a positive 4x squared. I know that some of you are used to the fact that they focus on the coefficients, but I don't want you to get used to that, because in some cases the last term is not a coefficient and it makes things difficult for you. So let's just focus on making sure that we are just taking the whole term with its sign. So that now that we have that, what we do is it's very simple. What are the terms of 4? Because now these boxes are just waiting for the terms of positive 4. So positive 4 can be produced by minus 1 and times minus a 4. Right, that's the first term. And then the second one, it can be a positive 1 times a positive 4. So we have those two. And take note of this. Because we are adding those two terms, we want to get a minus 5. So both must be negative. So this one cannot be part of that. And also, another one would be, we wanted to have, let's say, minus 2 times minus 2. And those two will give us a positive 4. But if you look into those two, when you're adding them, you get a minus 4, not a minus 5. So the correct ones is minus 1 and a minus 4. So we want to have a minus 1 and a 1 and a minus 4. That's what we are looking for. Now, how do we proceed forward? Now, we say that, okay, 2x squared minus 5x plus 4, is it 4 too? Or plus a 2? Plus a 2 is equal to 0. This means that we're going to have 2x squared what am I doing now? 2x squared. Instead of having this, we're going to have minus 1x minus 4x plus a 2 is equal to 0. Now that you have that, we group two terms. So we're going to group the first two. So you're going to have 2x squared minus x. Put these in brackets plus minus 4x plus a 2. Note that this plus, I added it and I took this part as it is and I plugged it inside the brackets so that you don't make mistakes of a sign. So now that you have this nice thing here, the next thing is look out for the highest common factor here. You can see that x is everywhere, so you're going to have an x and you're going to have 2x. If you divide 2x squared by x, you get 2x. If you divide minus x by x, you get a minus 1. And now here, what is a common factor? First here, the common factor is a 2. Take it out. Minus 4x divided by 2 is minus 2x plus positive 2 divided by 2, you get a 1 is equal to a 0. Now take note of this and that is not the same. So in order for it to be the same, we need to factor out a minus there. So you're going to have x and 2x minus 1 minus 2. And then if I'm taking the minus out, I'll be left with 2x minus 1 is equal to 0. So we have that nice thing. This and that is common, so you end up having 2x minus 1, and then you have x minus a 2, which is equal to 0. So 2x minus 1 is equal to 0, or x minus 2 is equal to 0. So for this thing to be equal to 0, either this is equal to 0, so 0 multiplied by anything will give you 0, or this is equal to 0. Anything multiplied by 0 is going to give you 0, or both of them are equal to 0. That's why we have an OR there. So now that you have this, then you're going to have 2x is equal to 1. When taking this from the left to the right hand side, it changes the sign. And then, which means that, and then you divide by 2 on both sides. So your x is equal to 1 over a 2, or x is equal to a 2. So this is what we're looking for. And then we are done with this particular question. Yeah, it's long, but it's doable. Rationalize the denominator of the expression. So we want to rationalize that now. So how do we rationalize? We have the square root of a minus square root of b divided by square root of a minus square root of b. Let me check where is the positive. The positive is in the numerator. So we have this, and we want to rationalize the denominator. The meaning of rationalizing the denominator is mean multiply both the numerator and the denominator with a new term, which is the same as the denominator, but changing the sign that is in between. So this is going to be the same as the square root of a plus the square root of b all over the square root of a minus square root of b. Now, what is the conjugate of the denominator? The conjugate of the denominator is going to be square root of a minus square root of b, but now we change the sign in the middle, so it's going to be plus all over square root of a plus the square root of b. Take note that we are multiplying and then dividing, so that we're not coming up with something new. We're multiplying by 1 essentially. So that's what is happening there. How you rationalize, change the sign. If the question was rationalize the numerator, we going to change this sign, and then here we're going to have minus and a minus. But it's rationalizing the denominator here. So a plus b, and that is the same as square root of a multiplied by this and that. So it's going to be that squared, and then that one and that one is still going to be plus square root of a times square root of b. This one and that one is going to be square root of b times square root of a, and then this one and that one is going to be plus square root of b, this whole squared. The same thing with the denominator. This and that is going to be square root of a, and then you square it, and then this and that is going to be plus square root of a times square root of b, and then minus square root of b and a, so it's going to be the square root of b times the square root of a, and then this one and that one is still a minus square root of b squared. And moving from there, you can see that this term and that term is the same, so we'll get two of these terms, and square root of a squared is the same as a, and of course we're assuming that a is defined there, and then this is going to be plus 2 square root of a square root of b, and then that one is going to be plus b. Whole thing divided by this term and that term is the same, except that the sign is different, so it vanishes. So you're going to have a squared minus, I'm lying, this is supposed to be a minus a b, because we have square root of a and then you square it up. So we have this nice thing. The next thing that one can do is realize that these are inside square root, both of them, so we can just combine them. So you're going to have a plus 2 square root ab plus ab all over a minus b. This is the final answer to our problem, and that's it. And we're going to stop there. Thank you.